asymptotes before we select a function and graph it. So vertical, very simple. Every time we have a number divided by 0, whenever this happens, like for example, 1 divided by x plus 1 and x minus 2. So if we have this function, we know that x cannot be -1, x cannot be 2, so both of them are vertical asymptotes. X plus 1 does not cancel, I should say simplify, sorry, it does not simplify with a factor at the top of x plus 1. X minus 2 does not simplify with another factor at the top of x minus 2. Everything stays as is, so this function has two vertical asymptotes, one at -1 and one at 2. So that was easy. Yes, we have to remember, find limits, always. So it's not sufficient to say x equals -1 is a vertical asymptote. No, I also have to find the limit as x approaches -1 from the left and the limit as x approaches -1 from the right. Of course, the same thing for 2. So limit as x approaches 2 from the left and limit as x approaches 2 from the right from the function, of course. So it's not sufficient to say, here, x equals -1 is a vertical asymptote. No, I have to determine these limits. And they have to be either both going to positive infinity, so infinity, infinity, infinity. Second option, negative infinity, negative infinity, of course for both, or positive infinity, negative infinity. That's the third case, or negative infinity, positive infinity. So 4 different situations. Positive, positive, negative, negative, positive, negative, or negative, positive. So the answer have to be these. So that's all about vertical. Now number 2, horizontal. There are 2 types of rational functions. Rational functions. For anything else, I have to look at the problem. I can't draw a conclusion. But for rational functions, I'm sure you remember from Math 137. These were discussed then. So what happens is there are 2 possibilities for horizontal asymptotes. One is degree n over degree n. Same degree, in other words. Same degree. And there is another one. Degree n and degree strictly greater than n. Degree 1, degree 2. Degree 1, degree 5. Degree 2, degree 10. Degree 5, degree 15. Larger than this one. This one is very simple. What is the horizontal asymptote in this case? Always 0. Horizontal asymptote. So if the degree of the numerator is 2 and the degree of the denominator is 3, the horizontal asymptote is 0. Here, if you remember, does anyone remember what will be the horizontal asymptote for this case? When both have the same degree? Anyone remembers?
It would be the coefficients over like the
leading coefficient, awesome. Y equals, I'm not going to write it here. I'm going to put an error because I don't want to squeeze it in. Perfect. Thank you so much, Amara. Thank you. So that's my page 2. So in this case, of degree n over degree n is the leading coefficient over the leading coefficient. Here's an example. So if I have f of x equals 3x squared minus 1 over 4x squared plus 7x minus 1, the leading coefficient over the leading coefficient, because these have the same degree. Degree 2, degree 2. So in this case, y equals 3/4 is the horizontal asymptote. Every time the degrees are the same, the horizontal asymptote is the leading coefficient over the leading coefficient. Now remember, these can be twisted. You have to look for the leading coefficient. You have to look for the leading coefficient. It may be here on the third term. So I may have 7x minus 1 plus 4x squared. It doesn't matter. Rearrange it correctly, and then you will identify the leading coefficient and the leading coefficient. So that's number 2, horizontal asymptotes. Now there is number 3, last one, slant. Slant asymptote is found only in one specific situation, only one, when it's degree n plus 1 and degree n. What does this mean? When the degree of the numerator is exactly by 1 unit larger than the degree of the denominator. Here's an example. F of x equals x to the third plus 1 over x squared minus 3. Degree of this is by 1 larger than this. This is degree 2, this is degree 3. 2 plus 1. Only this function has the slant asymptote. Only this one. And it has no horizontal. If a function has a slant, a rational function has a slant asymptote, cannot have horizontal. If it has horizontal, it cannot have slant. Good. So now I'm going to open on page 305. So I hope I'm not logged out. Where is my book? Your session has expired. Thank you. Oh, my session has expired. I just opened the book. It already expired. Okay. So 305, I want chapter 3. It doesn't matter, but let's say this, this, and this. And we want 305. I would like us to graph a rational function. Let's choose one. So we looked at the first step here. So the first step was find vertical asymptotes. We did. The second step, if you'd like, determine the horizontal asymptote of each function. If none exists, state that fact. Okay, so here's the first question, 19. What is the horizontal asymptote of 19?
Zero.
Yes, because the degree of the top is smaller than the degree of the bottom. Awesome. What about 25? What is the horizontal asymptote for 25?
Four.
Excellent. It's the same degree over the same degree. We look for the leading coefficient over the leading coefficient. Awesome. Excellent. What about 17?
Six, 8.
Yes, or 3/4. Excellent. Perfect. What about 23? What is the horizontal asymptote for 23?
Wouldn't that be a slant?
Exactly. Thank you so much. Awesome. It cannot have a slant horizontal asymptote because the degree of the numerator is 3, the degree of the denominator is 2, and that's exactly the only case of a slant asymptote, and it cannot have a horizontal. Awesome. Great job. Okay, now they want us to do the whole thing, whole spiel for these functions. So let's choose a function. We cannot choose 42, 41, 42 just yet. We will, but I would like to work on a different problem first, and then we'll come back because I have to show you how to determine the slant asymptote for this. So let's start with a simple example. Anyone would like to choose, or I will?
36.
36. Very good. So let's start with 36. It's a very good one. And in 36, we have f of x equals 1 over x plus 2. Awesome. Good pick. Okay, excellent. So I get my table going right away. X, f prime, f of x, and the second derivative. Perfect. We have to start with the domain. Once we fill up the table completely, then we're done, we can graph it. Can anyone give us the domain of this function? Domain of this function.
I'm not sure, but is it like negative infinity to negative 2 union negative 2 to infinity?
Very good. Excellent. Negative infinity, negative 2, 0, infinity. Excellent. Undefined at negative 2. Good. Can I simplify x plus 2 with a factor from the top? Is there a factor of x plus 2 at the top? I know it's silly, but I just want to emphasize something. Is there an x plus 2 at the top to simplify?
No.
Of course not. So then x equals negative 2 must be a VA. Mandatory. Good. At this point, we want to determine everything we can about the function. What does that mean? Well, the value at 0, if it has x, if it has a y, an x-intercept, and these limits. Can anyone tell us what is the horizontal asymptote of this function? And I will put it in right here. Anyone? Which type is it?
Is it 0?
Yes. Higher degree in the denominator. Remember, we always discuss that. Small over huge. That is always 0. Small over huge at infinity. So I make myself a note. Y equals 0 is the horizontal asymptote. Can anyone plug in 0 and tell us what we get? 0 always has to be in the table.
1/2.
Very good. 1/2. Now we have to determine these limits. Remember how we do it. We plug in a number from the left of negative 2. I'm not going to put it in the table. I don't want to put in stuff that I don't really need. But just imagine that you plug in here negative 2.1, negative 2.1. Plug it in and tell me the limit. Okay, I think was not clear what I was trying to say. So let me say it again. We want to find the limit as x approaches negative 2 from the left from 1 over x plus 2. And we want to find the limit as x approaches 2 from the right from 1 over x plus 2. X minus x equals negative 2 is a vertical asymptote. I know the answer. I don't know the sign. I know the answer. Why I know the answer? Because x equals negative 2 is a VA. These have to be infinities, but I don't know the sign. Can anyone give us the sign?
Positive.
So negative 2.1, negative 2.1 plus 2.
Oh, negative.
Exactly. Now with negative 1.9, negative 1.9, negative 1.9 plus 2.
Positive.
That's it. That's all I needed. Negative infinity, positive infinity. At this point, I can say I exhausted this. There is nothing else. I cannot set this equal to 0 because a fraction is 0 when the top is 0, but that cannot happen. I finished with this. Now I'm moving on here. So I want to find the first derivative. So let's find the first derivative. Remember what I like to do. So for the function f of x equals 1 over x plus 2, how do you think I'm going to rewrite it? Is there another way of rewriting this so I can easier differentiate? Is there another way of writing 1 over x plus 2?
-1.
Exactly. This is so much easier than this. You can say, no, I want to differentiate using the quotient rule. Fine. But be very careful because the numerator prime is 0. Not to get into that trap of putting 1 or something else. So that's why I prefer this. So can anyone differentiate this for us? Anyone, please? Anyone?
Just negative x.
Negative x plus 2 to which power?
-1.
Careful.
0.
We subtract.
-2.
Yes. Times. Remember when I was silly? Times. What am I expecting you to say?
1.
Yes. Times the inner function prime. Awesome. Which is 1. So there is no need to write anything. Now I will go back to this. So, critical numbers. Critical numbers come from two sources, either this or this, when the function exists. So this function is not defined at which x value?
-2.
Right, but the function is not defined at -2 anyway. It's not defined at -2. So it cannot be a critical number. Good. Now, can this function be 0? We are discussing the second source. Can this function be 0? When is a fraction 0? Only when a fraction is 0, only when only 0 over a number is 0. So a fraction is 0 only if the numerator is 0. Can the numerator be 0?
No.
No. So this function